umat manusia dan alam semesta. Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Terus berpacu dalam keunggulan, lincah pembelajar untuk kehidupan. Inilah semangat baru, tekad raih kesempatan, wujudkan kampus terbaik selamanya.
Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah.
Mari bersama hadirkan masa depan dalam langkah dan pikiran agar selalu terdepan, berbekal ilmu dan jiwa pengabdian. Deras arus zaman takkan tertahan, majulah melangkah, oh majulah. Wujudkan kampus terbaik selamanya, wujudkan kampus terbaik selamanya, wujudkan kampus terbaik selamanya, wujudkan kampus terbaik selamanya.
Selamat datang di IPB University, kampus hijau penuh prestasi, dinamis dan penuh karya, unggul akademik dan risetnya.
Ayo masuk IPB, kampus terbaik penuh inovasi, berintegritas dan menginspirasi. Tunggu apa lagi? Ayo masuk IPB.
Beragam fakultasnya, asri dan hijau lingkungannya.
3, 2, 1, go! Here we go! Welcome to ITB University Bogor, lokasinya teduh suasananya, bertemu teman dari seluruh Nusantara, Jawa, Sumatera hingga Papua. Kita bersama raih asa seluasnya, gapai cita bersama banggakan orang tua. Now we are here again, call us ITB Nation, satu IPB untuk satu nation. Haha, come on!
Berpadu satu raih asa, bersama kita raih cita.
Yakinkan hati untuk berdedikasi. Tunggu apa lagi? Tunggu apa lagi? Tunggu apa lagi?
Ayo masuk IPB,
Assalamualaikum warahmatullahi wabarakatuh. Good morning, best wishes for all of us. Welcome to the parallel session of the ISOTOBAT 2026, organized by the Directorate of Strategic Studies and Academic Reputation of IPB University. Please let me introduce myself. My name is Risa, and I will be the Master of Ceremony for this parallel session under the subtheme Bioresources in Food and Nutrition for a Healthier Future. Thank you very much to also welcome to our moderator for today's session, Dr. Arifin. Thank you for coming, Doc.
Yeah, thank you. Good morning.
Okay, before we begin, please allow me to explain a few important rules for this session. Okay, the first rule is the rule presenters and audience members. All presenters are required to attend every session of the conference until the end of parallel sessions. Co-authors are welcome to join the conference without register. All participants, presenters, and audience must complete a presence form for each session, which will be shared via a Google Form link in the chat box. The MC will open each presentation session, which will then be led by the moderator. Invited speakers will have a total of 15 minutes, consisting of 10 minutes for the presentation and 5 minutes for the Q&A sessions. Each presenter will have 10 minutes in total, with 5 until 7 minutes allocated for video playback and the remaining time for the Q&A session. A presentation from will be accepted, mute, while videos are being played. And the last one is during the Q&A sessions, participants may share their opinions or ask questions by raising their hands or writing in the chat box. The moderator will invite them to speak in turn. Okay, before starting the presentations, I want to invite all participants in this Zoom room to turn on the camera, because we will take some. Bapak Ibu, please open the camera. Okay, I will start the photo session. 3, 2, 1. Once again, 3, 2, 1. Okay, thank you for your attention. Our moderator is Good morning, Dr. Arifin. Dr. Arifin is the lecturer at IPB University with research expertise in protozoology, microbiology, and veterinary. Okay, without further ado, I invite Dr. Arifin to lead our presentation session. Dr. Arifin, please, the time is yours.
Yeah, thank you very much, Risa, for the introduction. Yeah. First of all, good morning, everyone. Good morning, ladies and gentlemen, for joining our international conference for second day today. I'm very pleased to be as your moderator. And as introduced by Ms. Lisa, my name is Arifin. I'm from the School of Veterinary Medicine at IPB University. I think for the rules for today plenary session already explained by Ms. Lisa. So without further ado, I would like to invite for the first our presenter, because today we have 7 presenters for plenary session. For the first presenter, I would like to invite Mr. Farid Usmantoro. I think already joined with us, yeah. Mr. Fadi. Thank you for your joining today. So our next speaker, Mr. Faris Guswantoro from Research Center for Applied Botany BRIN. And the title of the presentation is Coixcla Jobi, Potential for Future Healthy Food, Bibliometric Analysis. So for the video will be assisted by Ms. Risa. Ms. Risa, could you please to help to play the video for Mr. Farid Guswantoro?
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It's an honor for me to be here with you today. My name is Farid Kuswantoro from Research Center for Applied Botany Brain, and today I would like to present my study with the title of Coixcla Potential for Future Healthy Food, a Bibliometric Analysis. For introduction, Coixcla is a multi-purpose plant species. It belongs to the grass family of Poaceae and has four infraspecific taxa. In the picture, you can see the edible Coixcla Pharma UN and the non-edible Coixcla Coixcla is nutritious and has many beneficial phytochemical as well as highly adaptable to environmental conditions. This condition made the species a very potential future crop, especially in climate change scenario that we face. However, to really harness the potential of Coixcla research are essential, and that raises a question on how scientific community approach Coixcla research over the years, who and where the publication was produced, and is there any topic change over the years. Thus, this research aim want to assess Coixcla research over the past year, especially from highly reputable Scopus database to answer that research question. This is a very simple and straightforward study. The first thing, we need bibliometrical data that we can recover from Scopus database. We use this prompt in our recovery regarding Coixcla, its nutrition, phytochemistry, and pharmacology, and limit our search on document type like article, review, conference paper, and projector. After the data was retrieved, we export the data as a CSV file and use it for data analysis using BiblioSigny and PhosViewer. The data we get from PhosViewer and BiblioSigny was then presented. And this is the overview of data from Scopus database regarding Coixcla research. We can see here that the research span from 1983 to today, 2026, it's come from 112 documents with annual growth of almost 5%. It comes also from up to 600 authors with average citation per document almost 16. Here in picture A, we can see that there is an
Something happened with the connection, Risa. Hello, Marisa.
Sorry, Dr. Arifin, I think there is technical issue.
Yeah, I think we can start with the result section. Yeah, Lisa. Yeah. Okay. I think the sound also, yeah, completely shared.
More significantly after 2020. Wang is the most relevant author, while Guangzhou University of Traditional Medicine is the most relevant affiliation of the authors. We can see here in picture D that some author work from very long time, but some author also start to work recently, which also in line with the increasing number of scientific production in recent years. Uh, Meanwhile, Journal of Ethnopharmacology is the most relevant source of the publication. In this slide, in picture A, we can see that China is the most country with the most scientific production regarding Goikhlat Hematopoeia. It's followed by India, Indonesia, Japan, and Korea. In picture B here, we can see that the rise of publication number was more significant early in China compared to the other four nations. However, interestingly, if you can see in here picture C, uh, India and Switzerland has more collaboration compared to the other countries. Meanwhile, in this slide, we can see that there in picture A that there is a fluctuating trend of average citation per year on Goikhlat Hematopoeia publication. However, China still holds as the country with most cited document, while Denmark hold the author with the most um, citation. Keyword analysis in this study found that there are three clusters of keyword. The first one, the red one, the second is the blue cluster, and the third is the green cluster. Overlay visualization of this keyword in picture B shows that there are a shift of keyword use from the purple. The other keyword we can found in cluster 1 to the more recent yellow keyword we can find in cluster 3. This mark the change in focus on Goikhlat Hematopoeia research over the years. As to this study result, we can conclude that research on Goikhlat Hematopoeia span from 1933 to today, with surprise in the last decade. China, India, Indonesia, Japan, and Korea lead the scientific production, but China, Slovenia, and Japan are the most cited countries. Topic evolution shows a shift from basic information of Goikhlat Hematopoeia to advanced medicine. Overall, there is significant rise in Goikhlat Hematopoeia interest, particularly in recent years, regarding its medicinal potential, which highlight the plant potential to support human health and livelihood. That's all from me for today. Thank you very much for your kind attention, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you so much for the presentation, for the good presentation from Mr. Farid Kusmantoro. Thank you also for Ms. Lisa. Okay, next I will open for the short Q&A. If from the participant, if you have any question, you can raise your hand, then you can ask directly to Mr. Farid Kuswantoro. At least one or two participant to ask the question. Any question from the participant? Oh, while waiting for the question from the participant, Mr. Farid, I have not question. I mean, I would like to get your opinion about the Quakes Lacrima Jobi. What the because you mentioned many publication rise during 2020, yeah, based on your data. So, in your opinion, what makes Quakes Lacrima Jobi an interesting topic for explore right now? Maybe.
Thank you for the question, Mr. Arifin and everyone. Good morning. Why COIC become interesting? I think because we are now searching for another food source. We know that by the climate change and everything, the disruption of caused by war, food security is very vulnerable. So that we learn or we try to found another source of food, and COIC being a very in close relation with rice, sorghum, and our crop, our crop, our general crop. It can be a solution, and then research also shows that it has a nutritional value comparable with those crop and other phytochemical that maybe lead them not only as a food but also as a functional food that can support our health. I think that's why COIC become very attractive in the recent years.
Yeah, thank you, Mr. Farid. Very interesting topic, yeah, for the
Yeah.
functional food also, yeah, for
Yeah, because it has a lot of phytochemical amino acid also. Our research shows that even the unedible variety, the hard one, also have a high protein content. So it's have a great potential for food security.
okay. Maybe one more question, your
Yes.
opinion. What is the challenge for the mass production maybe in the future? Is there any challenge?
COIC is produced in China. But the edible one, I mean, but then there is genetically koik, the edible koik come from the unedible one, and it lost almost half of the genetic diversity during the domestication timeline. So it become very vulnerable to something when because the gene pool is very narrow. It will, let's say, if there is a pest or uh, um yeah, let's say there is a pest, the it can harm the koi global population. That's the first. That the second is because it's not popular yet, so it it has very thick hull, so that it's not easy to extract the rice from the hull. It's more technical problem, make them not very popular with us right now.
Thank you, Mr. Farid.
Thank you.
I saw a license from Miss Melia. Okay, please.
Okay.
Thank you, Sir. This research, search for it is interesting for me.
Okay.
Congratulations.
Thank you.
I will question about evolution. I see the slide. Some overlap in the evolution picture. Yeah. Why? Why the overlap in the uh, group in apa? So lacrima. Why the
Quite laughing.
by some group in the lacrima jobi. Yeah.
I'm sorry, but if you mean that there is in the last slide, there is not an evolution of
Yeah.
Koik Lacrima Jobi, but it is
Yeah.
evolution of a topic, research topic on Koik
Yeah,
Lacrima Jobi.
about lacrima
Yes.
jobi.
Yeah. I think because as I mentioned previously, there is people now start to understand that Koik Lacrima Jobi has potential as a food source and healthy food, and maybe as a medicinal plant. So research now focus on them, focus on its metabolomic, its uh, genetic genetic effect on our health. Well, previously in earlier years, the research focus on the taxonomy, on the uh, basic thing of COIC like taxonomy and nutritional, a little bit nutritional only on proximate analysis and something like that, and then on habitat suitability, something, etc. So there is now a shift from the basic information of COIC to the more advanced information for our health to support our health directly. I think that's why there is a shift on keyword use of research on Koik Lacrima Jobi.
Thank you very much.
Yeah, thank you, Mrs. Farid and also Ms. Melia. I think because of the time, yeah, we have limited time. Thank you so much, Mr. Farid, for your presentation and also for very good information. Yeah, thank you. Okay, now we move to the next presenter. I think I have checked Ms. Siti Sumiati already around join us, yeah. Okay. Yeah, our next speaker from Siti Sumiati Solihat from IPB University. She will be present about in silico investigation of bioactive compound in royal jelly targeting alpha glucosidase for potential anti-diabetic therapy. Yeah, Ms. Lisa, could you play?
Assalamualaikum warahmatullahi wabarakatuh. Greetings everyone. My name is Sutismita Solihat, a master student of biochemistry at IPB University. It's a great privilege to present our research title in silico investigation of bioactive compound in royal jelly targeting alpha glucosidase for potential anti-diabetic therapy. The background of this research: diabetes is a massive global challenge. By the year 2050, global diabetes cases are projected to reach 853 million. To control blood sugar spikes after meals, patients currently rely on drugs like acarbose. But however, acarbose often causes uncomfortable stomach issue like bloating and diarrhea, which make patients stop taking it. And the methodology of this research, because of this side effect, we look for a safer, natural alternative that is royal jelly. And the first, we identify its active compound using a CMS testing. Then we test this compound using a computer-based approach. This includes molecular docking, drug safety screening, and movement simulation. And the first result, the binding energy, a stronger binding energy means the compound attach better the target enzyme. As shown in the table, the natural compound DGMP emerged as the best candidate with a score of 7.2 kilocalorie per mole. Amazingly, this beats the commercial drugs acarbose, which score 6.6 kilocalorie per mole. This proves that DGMP can block the enzyme much better than current clinical treatments. And the next, pharmacokinetic analysis using ADMET. A drug must also be safe and easily absorbed by the body. So we run ADMET drug safety, and in this table, adenosine proved to be a perfect candidate. It scored 0 violence on Levinsky's rules and had a great absorption score of 0.5. meaning it works very well as an oral pill. But meanwhile, the GMP had just one minor violation due to its phosphate groups, but it remained a highly promising candidate. And the next, visualizing the interaction stability. When we look at the 2D structure, we can see exactly how this royal jelly compound lock into the enzyme active site. The GMP forms a very strong and complex network of hydrogen bonds, and the next acarbose as our control, really more and simpler van der Waals force. And the next adenosine show solid anchoring using hydrogen bonds and P interaction, and 2-deoxyguanosine so solid anchoring using bonds too, hydrogen too, same as adenosine. And the next, propylcresol, on the other hand, really more on simpler van der Waals pores. And the next, to make sure these compounds, we run a 10 nanosecond movement simulation using ChatSplex. The visual models overlap perfectly. This proves that our compound successfully lock the enzyme structure in place even when the protein moves naturally. We also check the RMSF graphs, which show that our natural compound successfully calm the enzyme natural sticking, keeping the whole complex stable. And the next, mechanical toughness using iMods. We put the structure to a stress test using the iMod server to check their mechanical toughness. We'll look at a number called the agent value for the GMP. The score was 1.52 times 10 to the minus 4. And also we compare this against acarbose, which score 1.63 times 10 to the minus 4. Because these numbers are so close, it proves that the bond created by our natural royal jelly compounds are just as tough and resilient as the commercial drugs. And then the conclusion of this research, in conclusion, our research proves that bioactive compounds in royal jelly, specifically DGMP and adenosine, are more than just nutritional supplement. They have stronger binding affinity than commercial drugs, great safety profiles, and excellent stability. This natural compound hold immense potential to be development as next generation anti-diabetic drugs. And this bring me to the end of my presentation. Thank you for the all attention, and I welcome any question regarding this research. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much. Now I invite also Sumiati to join us. Okay, is there any question, participant? Yeah, from Paradisika, I check from the chat box. Maybe also you can check Ms. Sumiati. I will read the question. Has this research also analyzed the predicted toxicity of the ligand in relation to carcinogenicity and acute oral toxicity parameters? Please.
Thanks for the question and for the change. This research was analyzed in silico, but we have to analyze the toxicity test, and usually for the oral drugs, especially for anti-diabetic, it is oral herbal products. This using for this research. This research was using in vitro analysis before in silico test. for the workflow in vitro before and then in silico test. For in vitro, we test the BSLT or Brim stream lethality test for knowing the toxicity of the royal jelly, and then the result show us the LC50, and then we conclusion that our sample is secure for the drugs oral medicine. And then this research and so actually presented about the ADMET parameter for the screening oral medicine. It was a test using ADMET, and it show us the metabolite, 5 metabolite best metabolite show us the majority of the metabolic secondary secure for being the medicine herbal. And then for the carcinogenic, it's not test in this research because the BSLT and ADMET test is enough for our research. Because the carcinogenic, it's for cancer, it's too strongly for this test, and then not really need for this research. I think.
Okay, thank you. So the toxicity parameters and toxicity parameter already done, yeah, for this one, but the carcinogenicity is not how to say, it's not related with your research. And then I found also one more question from Miss Anna Marliana. The bioactive compound that found will examine in vitro assay. What assay you will choose in vitro assay to validate as anti-diabetic agent? Sorry, the mic is still mute. Yeah.
Thanks for the question. For the bioactive compound, it's get by LCMS screening, and it's after in vitro screening using toxicity, and then for the in vitro in silico for screening by structure between metabolic secondary and alpha glucosidase as enzyme in our digestive system. And then to validate the antibiotic agents, we will using alpha glucosidase enzyme for inhibition using the royal jelly wall compound. We will extraction using buffer saline phosphate, and then we will inhibition, and we will now to parameter inhibition using IC50.
Yeah, thank you. I think because of time also we need to close for the second presenter. Thank you so much, Ms. Siti Sumiati, for the presentation and also for the answering the question from the participant. Thank you so much. Okay, now we move again to the next presenter. I check, yeah, Mr. Andreas Romulo already here, yeah. Okay, our next speaker is Andreas Romulo from Bina Nusantara University, and the title of this presentation is Enhancing Nutritional Value of Processed Cheese Slices through Soy Protein Isolate, a physicochemical study. Okay, you can play the video.
Good morning, respected chairpersons, distinguished participants, and fellow researchers. My name is Andreas Romulo from Food Technology Department, Bina Nusantara University, Indonesia. Today, me and my colleague, Teresia Evelyn, would like to present our research entitled Enhancing Nutritional Value of Processed Cheese Slices through Soy Protein Isolate, a physicochemical study. This presentation consists of 5 sections: introduction, objective, methodology, result and discussion, and conclusion. Recently, the development of alternative cheese products has attracted significant attention due to increasing consumer demand for healthier and more sustainable foods. One important approach is a partial substitution of milk protein with plant-based protein sources. And among these, soy protein extract is a promising ingredient due to its high protein content and good functional properties. However, when we replace the dairy protein in a cheese system, it's challenging due to it may affect the texture, color, and overall product quality. Therefore, hybrid cheese products, which combine animal-based ingredients and plant-based ingredients, are considered a promising strategy to improve the nutritional value while maintaining a cheese characteristics. Based on this background, this study aimed to determine the effect of different concentration of soy protein isolate on the physical and chemical characteristics of the processed cheese. This study used a completely randomized design with 5 treatments. Soy protein isolate was added at concentration of 0, 5, 10, 15, and 20%, and coded as P0 to P4. The formulation consists of curd, soy protein isolate, milk, water, oil, STPP, trisodium citrate, and salt. The cheese samples were prepared by first processing curd from UHT milk through acid coagulation. Then all ingredients were mixed and heated using a double boiling method at 90 degrees to 100 degrees Celsius for around 2 minutes. And after that, it was molded and cooled to obtain the processed cheese. And this cheese was analyzed for its physical and chemical content. The results from Table 2 show that soy protein isolate substitution significantly affected all physicochemical parameters. For first, the pH increased from 7.09 to 7.47 in P4, and this could be related to the protein composition and the buffering capacity of the soy protein isolate. In terms of water activity, the value are slightly decreased with increasing of soy protein concentration, indicating stronger water binding within the cheese matrix. In terms of texture, the hardness value increased substantially from 1.06 to 4.2. This indicates that the substitution of soy protein isolate concentration in higher amount form a denser and firmer protein network structure. For color analysis, the L value or the lightness value decreased as the soy protein isolate concentration increased. It means that the cheese become darker when the curd was substituted with a high amount of soy protein isolate. At the same time, the A value and B value indicating the reddish and yellowish tones. And the total color also increased significantly, showing visible color differences between the treatments. The proximate analysis also shows significant changes after soy protein isolate substitution. A moisture content increased from approximately 41% to 45%. This result suggests that soy protein isolate has a strong water holding capacity due to its hydrophilic functional groups. As content also increased slightly because soy protein isolates contributes an additional mineral content. On the other hand, fat content decreased significantly from 46 to 32%. This occurred because soy protein isolate replaced part of the milk curd, which originally contained a higher fat level. Protein content increased progressively with a soy protein isolate concentration and reached 11%. And in terms of the carbohydrates also increased, although the values remain relatively low for overall condition. In conclusion, soy protein isolate substitution to cheese product significantly influenced the physicochemical and approximate characteristic of the cheese. Increasing soy protein isolate concentration increased the pH, hardness, moisture, as protein and carbohydrate. And it also increased the redness, yellowness, and the total color of the cheese. On the other hand, the addition of soy protein isolate would decrease the water activity, the lightness value, and fat content. Overall, soy protein Isolate at the highest concentration at P4 produce the highest protein content with the highest hardness and also show the lowest fat content. Overall, soy protein isolated demonstrate strong potential as a partial substitute for milk protein in processed cheese production to develop higher protein and lower fat cheese product. That concludes my presentation. Thank you very much for your attention.
Yeah, thank you for the presentation, the video presentation. I would like to invite Mr. Andres Romulo.
Yes, good morning.
Good morning. Okay, if there's any question from the participant, we have slot for 2 questions from the participant. While waiting, I have a question maybe for Mr. Andres Romulo. From your result, you mentioned about the change of the characteristic of the cheese, yeah? And,
Yes.
And what the most interesting?
Salah satunya jeleknya di sini begitu. Takes time.
Sorry.
Sorry. Yes.
Yeah. From the changes of the cheese characteristic, what do you think the most noticeable or interesting from your result?
Yeah. Okay. Okay. So the first when we plan for this research, we try to, let's say, to substitute to reduce the cost production due to the higher price of the milk. And the second, we try at least to improve the protein content in cheese. So let's say the significant result is by substituting the milk with the soy protein isolate is the protein content at first. Okay. Then after we substitute, the result also shows that the fat content could reduce significantly. This is probably mainly due to the reduction of fat content from the milk because we substitute with more isolate protein. That's the more interesting. But in terms of other characteristics, for example, like in the pH, it keeps in the neutral acidity. But in terms of the texture, it becomes more harder. Yes, because it's probably due to the let's say the interaction of the protein with the casein. Probably the casein content in the cheese is reduced, so it changed the, let's say, the texture of the cheese.
Okay, so the challenge on only the texture, yeah.
Yes, the most significant one, yes.
Okay,
but in terms of the
thank you, Mr. Andres. There is one question from the participant, from Miss Lucy Istiqomah. Do you also measure the sensory assay for cheese with soy protein?
Yes.
Yeah, please.
Yes, in other research, we try to, let's say, not only searching for the acceptability of the product, but also we want to know which attributes could influence the characteristics. So in other research, we have, let's say, we try to conduct more, let's say, more deep in sensory analysis.
Yeah. Yeah, thank you so much, Ms. Lucy.
Thank you.
Maybe one more question. Is there any question? Let's check the time. Okay, the time is up. Okay, thank you so much, Mr. Andres.
Thank you so much. Thank you so much.
Insightful presentation, also the sharing for your research. Yeah. Okay. Now we again move to the next presenter for Bio 010. Mr. Mulyanti is already here. Yeah. Okay. Our next speaker from Miss Meliati from Biology University of Bengkulu. The title of the presentation is Phytoplankton Biodiversity in Rivers with Minimal Anthropogenic Disturbance and Prospect as a Future Food Source. Okay, we can play the video first, then we move to the question and answer. Yeah, please.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Meliawati
from the Department of Biology, University of Bengkulu. Today, I would like to present our research entitled Phytoplankton biodiversity in rivers with minimal anthropogenic disturbance and prospect as future food source. This study was conducted in the Oram Rivers, Lebong Regency, Bengkulu Province, Indonesia. Background and rationale. Rivers with minimal anthropogenic disturbance generally maintains better ecology, stability, and water quality. One important aquatic organism in rivers ecosystem is phytoplankton. We know phytoplankton are microscopic photosynthetic organisms that function as primary production, oxygen supplier, aquatic bioindicator, and foundation of aquatic food webs. In addition, several macroalgae species have high nutrition value and potential sustainable for future food and feed resource, especially for freshwater aquaculture like shrimp or fish. Research problem. This study is conducted to answer three main questions. One, how diverse is phytoplankton community in the Oram rivers? Two, what is the structure of phytoplankton community? And three, which phytoplankton taxa have potential as future food for aquaculture? Next, research objective. This objective of this research is to identify phytoplankton diversity, to analyze community structure, and to evaluate potential phytoplankton as future source. Study area. This research was conducted in Oram River, Lebong Regency. Sampling was performed at 4 stations. Station 1 represented the upstream rocky area with strong current. Station 2 was located near dam, low currents, and Station 3 was surrounded by bamboo vegetation and residential area. Station 4 represented the downstream area near rice field. So it is a station as different environmental characteristics which influence phytoplankton composition and abundance. Next, methodology. This study used a stratified sampling for 4 stations. Phytoplankton sampling were collecting with plankton net and analyzed by microscope in the ecology laboratory, University of Bengkulu. Community structure was analyzed using abundance and non-linear diversity index, evenness index, dominance index, and similarity index. Results. The results show high phytoplankton biodiversity in the Oram River. In class Basilarpita was richest class. Yeah. So totally 7,682 individual and 52 species, and then 8 classes. Identify class can see in slide: Basilarpita, Cyanophyta, Zygonematophyta, Chlorophyta, etc. And dominant group was Basilarpita or diatom. Why Basilarpita was richest another class? Because diatom are known for high adaptively efficient nutrient utilization and rapid reproduction. So their dominance often indicates relatively good water quality and stable environmental condition. Species richness varied among stations. Can we look in station? So station 3 has highest species richness, and next station 1 I guess abundant, and station 4 had to lower abundance causes with higher turbidity and lower light availability. High evenness and low dominance suggests a stable and balanced phytoplankton community. This is interpretation result of this research. You can see in slide. Community structure indicates each prime diversity blue color, evenness to orange color and dominance green colors. Main nutrition advantage-nya, potential exposure for sure. Why? And which? This is example Scanadesmus, Protococcus viridis, tetrahedron, actinostrum electric. And this way, because the phytoplankton in the genus, several genus, noticed before, high protein content and strong essential amino acid profile, rich in vitamin, mineral, pigment, bioactive metabolism, vascular and low land use demand support sustainable production, sustainable for functional food supplement and aqua feed application. Okay, like this, naturally formed, with low distance, high phytoplankton diversity, stable community structure, and food feature potential food and feed in aquaculture, especially freshwater. The Oran River supports this phytoplankton assembling despite some human activity along the bank. The combination high diversity, high evenness, and low dominance indicate ecology stability. Several taxons identified in study how promising for new natural feed or future food ingredient. Conclusion: the Orang River harbors 5 phytoplankton species from 8 classes. Basilaria pita was dominant and richness class in the community. Section 3 show high diversity, suggesting favorable ecological condition. Evenness was high and dominant was low across station, indicate a balanced community. Okay, thank you very much. See you next time.
Thank you for the presentation. Now I'll invite Ms. Miliawati for the Q&A session. Yeah, ready to join with us. Okay, we would like to invite for the participant for the one or two question. Is there any question from the participant? Okay, maybe I have one question, Ms. Miliawati, from your finding because you already check the biodiversity of the phytoplankton. Which one is the most promising for the future use? Yeah. Based on your opinion.
Okay, thank you. One potential, yeah.
Yeah, one potential.
Most potential to phytoplankton. I find one more like Scanadesmus, yeah. Yeah. And then Cytoceros. This is more potential because consists of protein, essential fatty acid. But this is in based on our research, just from the journal, yeah. This is like journal from journal sorry, jurnal yang kami temukan gitu ya.
So Canadasmus and Cytoceros, yeah.
Yeah.
So that one is the common phytoplankton,
Yeah.
specific place, or it's common we found the phytoplankton, that one. Okay, maybe from another participant, we still have 1 minute. Okay. Okay, because of the time, thank you so much, Ms. Miliawati, for presentation and also for the sharing for your research. Thank you.
You're welcome.
Thank you. Then we move to the next presenter. Our next presenter is Ms. Wayan Aryan Ananta from Udayana University. And the title of the presentation is Psychochemical Changes in Sugarcane Juice During the Processing Stage of Sugarcane Juice Drinks Using the Sterilization Method. Okay, please, Miss Risa, to play the video.
Hello everyone, I am Marliana Ananta and today I would like to present study research with the title Physicochemical Changes in Sugarcane Juice During the Processing Stage Using Sterilization Method. First of all, have you ever seen fresh sugarcane juice sold on the roadside on a hot day? Yes, sugarcane juice is popular because it is refreshing, naturally sweet, and often considered healthier than carbonated drinks. However, fresh sugarcane juice spoils very quickly after extraction due to its high sugar contents, moisture, and enzymatic activity, which can promote microbial growth and browning enzymatic. Therefore, maintaining the quality and stability of sugarcane juice remains challenging. Although processing can improve shelf-life and stability of this juice, it may also affect beneficial compounds such as phenolic and antioxidant. Previous study mostly focused on individual processing steps, while studies evaluating sequential processing and formulation are still limited. So, the question is, can the stability of sugarcane juice be improved without compromising its functional properties? Therefore, this study is aimed to evaluate the effect of sequential processing and bioactive formulation on the quality of sugarcane juice. For the methodology, fresh sugarcane juice underwent several processing stages including heating, clarification, filtration, dilution, formulation with lemon and ginger extract, and sterilization before bottling. After processing, we analyze several physicochemical and functional properties, including pH, Briggs, light transmittance, FTIR profile, total phenolic compounds, antioxidant activity, and prebiotic potential. So now, let us move to the result. Firstly, the pH gradually decreased from around 6 to approximately 5 during processing. This reduction was mainly caused by removal of buffering compounds like protein, phosphate, and mineral during flocculation. In addition, lemon addition further enhanced acidification due to its high organic acid content. In contrast, Briggs value initially increased after flocculation. It's because of concentration effect during clarification. However, after dilution, the soluble solid content decreased to around 9.6 to 8.3 Briggs and relatively stable across all formulations. A similar trend was observed in the light transmittance analysis, where fresh sugarcane juice initially showed high turbidity and low clarity. After clarification and filtration, transmittance increased significantly because suspended particles were removed. After heat treatment and dilution can improve the quality of sugarcane juice. However, lemon and ginger addition slightly decreased transmittance due to additional dissolved compounds such as phenolic compounds and pigment. These findings were further supported by FTIR analysis, where all samples showed relatively similar spectral profile, indicating the major functional groups remain preserved throughout processing. Only minor variations were observed after thermal treatment, flocculation, and formulation changes. Next, thermal processing increased measurable phenolic contents. It may occur because heating can break down complex compounds like oligosaccharides into simpler like monosaccharides, making phenolic easier to detect. Sodium sulfite also helps reduce phenolic oxidation by inhibiting polyphenol oxidase activity. Among all formulations, higher lemon ratio result in higher phenolic content, where ginger-dominant formulation showed lower value. It because of dilution effect and presence of semipolar and nonpolar in ginger compounds. However, Higher phenolic content didn't always correspond to higher antioxidant activity. Although flocculation improved DPPH carving capacity, thermal treatment and dilution reduce antioxidant activity because thermal damage in phenolic compounds will increase oxidation. For prebiotic activity, fresh sugarcane juice showed the highest microbial growth because fermentable sugar remained intact. After thermal processing, microbial growth decreased due to substrate degradation to furfular and possible inhibitory effect. Meanwhile, lemon and ginger addition partially restored microbial growth, although the value remained lower than fresh sugarcane juice. In conclusion, sterilization and clarification successfully improved the stability and clarity of sugarcane juice while still maintaining important functional properties. Although antioxidant activity decreased after Tillman treatment, phenolic compounds and probiotic potential were still retained depending on the formulation. Therefore, optimizing processing and formulation may improve sugarcane juice stability without completely compromising its functional value. This is for the reference we use. That's all for me. Thank you for your attention.
Okay, thank you so much, Miss Aliana Ananta. Now I invite Miss Aliana already joined with us. Okay, from the chat box, we have one question. Yeah, Miss Adli, what kind of flocculant that you use in this product, and what is the function? Yeah, please, Miss Aliana.
Thank you very much, Ms. Lusti Istiqomah, for the question. So we use albumin as a flocculant because we want to develop functional beverage, especially for sugarcane juice. We use albumin because it's natural flocculant, and then it's safer than a chemical which might give chemical residues to the functional beverage. Not also that, because albumin can bind the small particles like suspend solid, fibers, and other chemicals compounds in the sugarcane juice become bigger flock, and it will make the sugarcane juice easier to filtrate. Maybe that's all.
Yeah, thank you, Miss Aliana. Maybe we still have one more question for Miss Aliana for this topic.
Yes.
No question from the participant. Maybe one more question from me, Miss Aliana. From your finding, from your result, yeah, what change during processing do you think is most important for improving the product quality?
From our research, let me repeat it one more time. So, with the several processing stages, which one is the compromising with the physical chemical changes in sugarcane juice? Okay, from our result, the minimal changes in physical chemical changes were found in the flocculation stage because it was compromising the phenolic compounds lesser than the sterilization one. It improved the clarity, and it will improve the more overall acceptance of the sensory because of the clarity was reduced. Because the clarity of sugarcane juice improved, then the overall acceptance of the consumer will improve. So it will, if someday the sugarcane juice become commercialized, and it will very potential to develop more in the flocculation stage one.
Flocculation stage. Okay. Thank you so much, Miss Arliana, because also time, we have limited time for today. Thank you so much again for the presentation, also for the sharing your research. Thank you, Miss Arliana. Okay, now we move to the next presenter, I think the last two presenter is the same presenter. For the sixth presenter is Felicia Tejakusuma from Kasensart University, and the title of the presentation is Influence of Carrier Oil Type and Oxidative Stability, Color, and Consumer Acceptance of Chili Oil. Now we play the video.
Good afternoon, everyone. My name is Felicia Tejakusuma, and today I would like to present my research entitled The Influence of Carrier Oil Type on Oxidative Stability, Color, and Consumer Acceptance of Chili Oil. As a background, we know that the global industry has gained an interest for functional food with a sensory appealing, and one of these is chili oil, which represents a cornerstone of diverse culinary tradition, particularly in the Southeast Asians. We know that in chili, capsaicin is the main component in chili that give a pungent and also the spicy flavor that is very unique. However, as we know that the efficiency of the extraction is really fundamentally governed by the physiochemical properties of its carrier oil, which acts as the solvent during the infusion process. That's why in this research, we have the objective is to investigate the influence of the palm, coconut, soybean, and olive oils on the color, capsaicin recovery, total phenolic content, antioxidant capacity, oxidative stability, and the sensory acceptability of the chili infused oil. For the methodology itself, first we are using the fresh chop by Panjang Lombok from the local market. And after that, we sort it to ensure the uniform maturity. Then the pepper will dry using the hot air at 65 degrees for 12 hours. Then we mill and sieve to obtain the pepper powder. After that, we prepare the chili oil using a thermal infusion. So we combine the pepper powder with its carrier oil at the ratio of 1:2, and we heat it until it reaches 120 degrees and hold it for 5 minutes in the room temp under conscious stirring. Then after that, it was cooled at room temperature and we obtained chili oil. Then we subjected our sample for physiochemical analysis such as color, phenolic, antioxidant, and also lipid oxidation. And we also measure the capsaicin extraction using SPLC, and for the sensory evaluation, we are having the hedonic test. Okay, now so we are entering the result section. So first here we could see from table 1 that actually olive oil exhibits the lowest L value due to the presence of endogenous chlorophylls and also the pheophytins in unrefined olive oil, which will contribute to lower likeness compared to palm or the soybean oils. And we could also see that actually coconut oil show the highest L value. It's likely because it contains medium chain fatty acid that provide less steric hindrance and a lower refractive index. And for the table 2, we have the pungency and also antioxidant parameters of several chili oils. And we see that actually here, palm oil show the most efficient carrier for capsaicin recovery, followed by the soybean. And it is because by the presence of the long-chain fatty acid in the palm and soybean oil. In contrast, coconuts show the lowest recovery, and it is because it contains more medium-chain triglyceride structure that provide a less favorable solvent domain for larger lipophilic solutes. Okay, now we're moving to the results of the sensory section. So we could see actually from the table that palm oil was the most preferred sample across all sensory attributes, and it's achieving the highest overall scores. And its highest appearance score also correlates with the objective research data, while its pungency score reflects the highest capsaicin concentration. In contrast, from the table, we could see that the lower preference scores for olive and coconut oils are plausibly attributed to the carrier-derived sensory interference. For example, for olive oil, its bitterness and pungency are well-established sensory attributes associated with its phenolic fraction. And besides from the table, we could also see that based on the PCA plot, the palm oil is our cluster with desirable chili attributes, such as lingering heat, pungency, red color intensity, and also fresh chili aromas, whereas the olive and also the coconut oils were clustered with kind of like the off-odor attributes with kind of like the brown color, bitter, mouth coating, smoky, and also some oxidized or rancid aroma. Okay, and moving to the conclusion, so we could conclude that actually the type of carrier oil really influence the pigment expression, bioactive transfer, oxidative stability, and also the sensory perception of chili oil. We could also see that actually olive oil produced the highest phenolic content and antioxidant activity. However, its overall sensory acceptance was not the highest. And palm oil provided the most favorable overall balance, delivering the strong capsaicin transfer, low peroxide value, and the highest consumer liking across the key attributes, indicating both good oxidative stability and sensory compatibility with the chili infusion. Another oil, which is soybean oil, showed acceptable sensory score but exhibited the highest peroxide value. And the last oil, which is coconut, produced the lightest oil but lowest capsaicinoids, phenolics, antioxidant activity, and overall acceptance. It's indicating that it is less suitable as a carrier when the goal is a strong chili character and broad consumer preference. That's why we could have a conclusion that out of the four types of oils, palm oils appear to be the most robust candidate for consumer-oriented chili oils, whereas olive oil may be better suited for niche positioning, emphasizing antioxidant-related value. That's all for my presentation. Thank you for listening.
Yeah, thank you for the presentation. Now I invite Ms. Felicia Tejakusuma to join with us for the Q&A section. Ms. Felicia is already listening. Yeah. I invite to the all participants to have, if you have any question for Ms. Felicia Tejakusuma.
Oh, okay. I
Okay.
think there is some question.
Okay, there's one question from Anna Mardiana. What panelists for assessment of sensory profile?
So actually for the panelists itself, we are having like a total of 50 panelists, and we're using just the one that is around the university, around Venus University. So it's either like the lecturer or maybe another student or also another faculty staff.
Yeah, thank you.
There is the specific panelist like must be consume or just all of people can.
Oh, actually, like it's kind of quite general for the panelist selection, but we make sure that
Sensory
they
assess.
yeah, but we make sure that they could eat spicy or like have a tolerance in spicy.
Oh,
What's
the specific panelist, yeah, for that one. One more question maybe from the participant. Maybe I have one question, Ms. Tejakusuma. From your result, which result did you find most interesting in terms of consumer preference or product quality?
Oh, for the consumer preference, I think like the most interesting thing is if you see like in the PCA plot, I think the difference between kind of like, for example, the palm oil, and then if we compare to like the coconut and olive, because for the palm and also the soybean oil, they have like no pungency, no oxidative, no mouth coating and anything else. But for the olive oil and coconut, we could see that it's not really preferred by consumer because bitter, pungency, and kind of like it's weird, the taste.
Yeah, okay. Okay, thank you.
Thank you.
Yeah, one more question maybe. We still have 1 minute for this section. Okay, if there is no question, thank you for Ms. Felicia Tejakusuma, but please stay tuned, yeah, because you are still for the last presenter for today. I mean, for the next presenter. Okay, thank you. Now we move again to next presenter with the same speaker, Ms. Felicia Tejakusuma from Kansas University. And for the title is Effect of Cricket Flour Edition on Physicochemical Characteristic of Traditional Crackers. Yeah, please you can see and watch the video first.
Good afternoon, ladies and gentlemen. Today I'm Felicity Jakusuma, and I would like to present our research entitled Effects of Cricket Flour Addition on Physiochemical Characteristics of Traditional Crackers. As a brief introduction, we know that the rapid growth of the global population and is combined with rising demand for animal-based protein has placed a significant pressure on conventional food systems. We could see here from the graph that actually in 2061, United Nations already predicted that our population will reach up to 10 billion people. And besides, we know that the traditional meat production has contributed heavily to greenhouse gas emission. And that's why the market of global edible insects keeps increasing its years, with cricket ranks second in the market. Cricket itself has been considered as a promising source um, of alternative protein because it contains a high content of protein, around 45 until 70%. And besides proteins, it also contains all the essential amino acids that are needed for our balanced diets. Moreover, cricket itself are high in vitamins, mineral, and it makes them a stronger candidate for food fortification. However, despite those advantages, we also have some limitation, actually in kind of like in the traditional practices, which is about entomophagy or the disgust feelings of eating insects. And one of the effective strategies to enhance the acceptance rates of insect in the consumer is by incorporating them into familiar food products. And in Indonesia, we will have crackers. It is a widely consumed snack in Indonesia and will offer a suitable medium for delivering protein fortification through cricket flour. That's why in this research, our objective is to develop a cricket flour-based crackers, and we would like to evaluate their chemicals and also their sensory characteristics. Okay, now I would like to explain about the methodology to produce the cricket crackers. So first, before we utilize the cricket flour into crackers, first we would like to process the raw crickets to become the cricket flours. So first we wash them and then we boil it for sterilization, and then we dry it using the oven drying, and then we grind them into fine flour, and we would like to obtain the cricket flours. And after that, we incorporated the cricket flour to crackers. And here we have three kinds of formulation. CF is means cricket flour, so it's the 0%, 5%, and also 10% of cricket flours. And all of these crackers, we would like to undergo some analysis. We have here the physiochemical analysis, including lightness, hardness, and also the expansion ratio. And after that, we would like to undergo to do the sensory evaluation using hadronic and follow-up by ranking test. And after that, the best formulation will be done by proximate analysis. Okay, so here we already here at the result and discussion section. So actually on this side, this slide presents a result and discussion on the physical properties of the cricket crackers. So on the first table, we could see that this is a table that talks about the hardness and also the color, the influence of cricket crackers to the hardness and colors. So we could see that cricket flour addition actually decreased the lightness values significantly, especially if we compare to the raw samples. And is it normal? Because this darkening trend can be attributed to the natural color of cricket itself, with its a dark brown. And we could also see that the cricket flour addition will increase the hardness and decrease the expansion ratio. And it's also pretty normal because we know that cricket is really high in protein, and it contributes to the hardness, which is interfered by the starch gelatinization process, inhibit the expansion due to the formation of crosslinks in the matrix, and that's why it will resulting in a denser and harder texture of the crackers. And next, this is the effects, the addition of cricket flour to the sensory attributes. So first, actually, from the first figure, we could see that the significant difference were observed in the attributes of color, tactile texture, crispiness, and also hardness. And the good thing here is that there is no significant difference between the commercial crackers and also the addition of the crickets and in the terms of overall rating. And after that, after this, we follow up by a ranking test. So we could also see that actually all of them produce a similar overall ranking test, and there is no significant difference at all, which means that our cricket crackers, which is the 5% and also the 10% addition of cricket flowers, this is a good consumer acceptance. Next, we are choosing the 5% of cricket flower addition to conduct the proximate analysis. And we could see actually here that when we compare to the raw products, the fortified crackers with 5% exhibit a higher protein content is around 2.8% if compared to the commercial one. And then we could also see that actually the cricket crackers has a higher fat content, which is likely due to the natural lipid content in cricket itself, which cooled up to around 30% of fat. And these 30% of fat actually include beneficial of unsaturated fatty acids such as the oleic, linoleic, and will contribute to the overall lipid level in the final product. Therefore, to be conclude, our product, which is the cricket flour fortified crackers, basically exhibits a darker color if we compare to the commercial product. However, the overall acceptance, the overall product were well accepted by the panelists, as we could see by the similar overall rating score and also the ranking result if we compare to the commercial crackers. And then the proximate analysis on the CF5 or the 5% additional of cricket flowers show an increase in protein content by 2.8%, is which means it is a good nutritional enhancement that doesn't present in commercial crackers. That's all for my presentation. Thank you for listening.
Yeah, thank you. Now I again invite Ms. Felicia Tejakusuma to join with us for Q&A session. Now I invite to all participants to Q&A section for this last presenter. Okay, so while waiting, Ms. Felicia, from your finding again, what do you think the most promising outcome, of using additional cricket flour in food product?
So I think like the most promising one is the really increase in terms of the protein content, because cricket itself is known to have a really high protein content. But another interesting thing is actually if we add more crickets to the crackers, it will affect the sensory preference, because the crackers will turn really dark, and of course like the panelists will not like it, and also it will also decrease the texture and the crispiness and increase the hardness.
What do you think to reduce the color? I mean, to make it similar with the product, to make the panelist preference is more good. What do you think?
Yeah. Until now, I mean, if maybe we could mix it with another ingredients, but the problem is the cricket flour itself, the color is really dark brown. So I think it's quite hard to kind of like masking the color. So I think one of the way is we could reduce the concentration of the cricket.
Yeah, very interesting. Yeah, thank you so much, Ms. Felicia.
Thank you.
Okay, from the participant, maybe one question. Okay, if there's no question, again, thank you so much, Ms. Felicia, for your your very nice presentation. Yeah, for the last presenter, thank you so much. Yeah. Okay, I think Ms. Felicia is the last presenter, so I will close for today presentation before I give back to the Ms. Risa. So ladies and gentlemen, thank you so much for your active participant, for speakers, to the participant, and also for the organizing committee for today international conference. I have a very great day. Yeah, have a great day for all of you, and also and see you for the next opportunity in the next conference in maybe in IPB, maybe in another university or in the another event. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. Thank you, Ms.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Arifin, for leading today's presentation. We are so pleased to have you as our moderator today. I hope we can meet you on another occasion, Dr. Arifin. Once again, thank you.
Thank you.
Okay, and ladies and gentlemen, we will now take a short break until 1:30 p.m. So we will expect you to rejoin this meeting room at 1:30 p.m. And before you leave, please make sure you have completed the attendance form. The Google form link was shared earlier in the chat box, or you can scan it in the slides. All right, I will see you again in 1:30 p.m. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Salam.
Terima kasih banyak, Dok
Ya,
Arifin.
makasih Mbak Risa. Izin live ya, Bapak Ibu.
Silahkan, Dok.